Over the course of the Code Green podcast series, we've engaged with leading experts at the intersection of AI and climate. Our guests have shared thoughtful insights on some wicked problems, prompting us to ask how we can shift gears from a business as usual approach to a more intentional trajectory for digital growth. They've highlighted the role of critical AI literacy among climate stakeholders and challenged current top down approaches to technology development. Throughout our conversations, they've centered environmental impacts as a core, unavoidable component in technology and society discourse, urging a whole of system approach to AI supply chains. In this final episode, we return to some of these foundational topics with Luis Felipe Hosado Muyo and Hanyuan Karen Wang. How can climate tech innovation and funding address the needs of those most vulnerable to climate change? What funding models work best for collaboration? And finally, how can we ground solution building efforts through partnerships that foster agency and autonomy for all stakeholders? Hello and welcome to the final episode of the Code Green podcast series, where we explore the intersection of climate change and artificial intelligence in Asia. I am Donna Matthew, Senior Research Associate at Digital Futures Lab. We are an India-based research organization that examines the impact of technology on society in the global south. This podcast is accompanied by a monthly newsletter where we showcase the latest scientific and socio-technical research at the intersection of AI and climate action. You can access both the podcast and our newsletter at codegreen.asia. Code Green is supported by Earth Venture Foundation, a not-for-profit initiative that supports scientific research to advance climate action. In today's episode, Luis Felipe Hosado Muyo and Hanyuan Karen Wang offer their insights from working on environmental issues and digital technologies. Hanyuan, who is CEO of Climind, discussed the need for intelligent tools that can pass complex environmental regulations and help businesses navigate overlapping compliance demands. She highlighted the importance of framing a strong hypothesis before extracting useful data, stressing the role of private sector involvement and localized climate technologies. Luis Felipe, professor of anthropology at University of Notre Dame, underscored how environmental challenges are inseparable from technological development. He discussed the need for responsible climate data stewardship that spans public, private, and community sectors. He advocated for data commons, a shared space of respect among experts and non experts as a middle path between public and private data models. We closed on a subdued note, examining the dangers of indiscriminate AI usage, which can harm the environment, and calling for more thoughtful, curated data practices amid ongoing tensions between financial incentives and ecological protection. Thank you so much for joining us today. Hanyan, maybe I can start with you. Tell us about Climind and your core problem statement. An example of a use case to illustrate Climind's scope would be great.
Thank you so much. Dana. Great to be here. So Climind, you might guess from our name, it's climate and the mind. So we bring AI in the climate sector as broadly, but more specifically, we hope to leverage the AI solutions to reshape the really low efficiency type of work in the broadly climate sector. So far we are applying this in the, for example, carbon market, ESG, and then different sector of green finance. And our users are those like knowledge workers. So they're using climate tool, for example, to search like carbon projects detail from broad documents, and then with a very easy access by the tool, the algorithm we develop. I think the vision, the hope here is because I've been in the position like spending hours, days, like trying to find the information from document, lots of document, and trying to prepare the reports. And that is like a very, I think a sector with very low adaptation on technology, especially AI. So I want to try to build a tool to change that. And that's like a bit natural of what Climind is doing now. It's doing.
Right. Could you also then maybe provide a particular use case where you're using climate information and also what you mean when you say information workers are looking for climate information?
To define the information worker or knowledge worker, if we have to give a landscape of the job market of climate, or you can name it. Like I think it just in the financial sector, like insurance sector, you need a new type of climate insurance. Or you in the banking sector, like we work with a even like a fintech team, or like product team. They have a green loan, green bond, and you can imagine there will be lots of due diligence or like paperwork you need to you need the staff to work on. And we'll also have rating clients. So the traditional like S&P 500 or some of the biggest rating company we've been working with, like they're spending tons of time trying to, for example, retrieve some information from the ESG or financial report, like with thousands of factors, in order to come up with a score, like the rating or like a physical climate risk. So that's like in the financial sector, but beyond that, we also work with like battery sector, the lithium battery recycling service providers. They need to know very well about the regulation legislation in, for example, Europe. Different country apparently is quite different. So beyond the language barrier, they also need to know very detailed, like if you want to set up a factory today in Germany, so how I do that, what kind of regulation you need to fulfill. It's hard to, I think, give one persona about the knowledge worker we work with, we provide service for. But broadly, if your work is impacted or related to sustainability, that's the area we're looking at.
Great. Thanks so much for that. LF, if I can come to you next, you've primarily worked on community participation, techno-scientific expertise, and open data and technologies. Could you tell us a little more about your work, the kind of communities you work with, and how it intersects with environmental concerns? And for our listeners, an example of your projects, maybe beyond the global north, but also giving us a flavor of the range of your work.
Sure. Well, thank you so much for having me in your podcast. My work is primarily dedicated to the intersection between computing and culture. I'm a cultural anthropologist by training, and I didn't start working with environmental questions in my work. I have been always working in the space of computing and really interested in what people do with computers and what people do with information technology and communication technologies. My work has been primarily dedicated to the production of free and open source technologies, how people coordinate collaborative arrangements to produce software, or free and open source software, open data, open hardware, open educational resources. And in my trajectory, the question of climate crisis, or the question of climate came as an urgency. It was a question that appeared in my work. So I was doing a research at the time, around 2010, in Japan, and very interested in understanding the differences between the formation of the free software community in Japan and other free software communities that I was familiar with in Brazil and in Peru, United States, Germany, Spain. And in 2011, we had a triple disaster in Japan. And I came to Japan 3 months after the disaster. That you will remember, March 11th in 2011, the Fukushima disaster, right? First, a big earthquake off the coast of Japan, then a tsunami, and the tsunami hit the Fukushima power plant, and then a big nuclear crisis unfolded that is still ongoing in the region, right? Not only for Japan, for the nearby countries, and for the Pacific, and I mean for the whole planet, fundamentally. So when this disaster happened, I happened to be studying, working on the question of free software development in Japan. And then I saw how technologists used open technologies to develop a radiation monitoring device using open hardware, using open data, and using free software. And that's kind of how the environmental question came into my work with full force. And I realized that I couldn't really continue to work with a question of technology without taking very seriously the environmental question. As the climate crisis imposes itself to our research agendas, is something that we cannot avoid. It's something that we all have to be concerned with and working on, regardless of the topic that we are interested in studying. So that's kind of in a nutshell how I got into this line of research.
It's very fascinating because we also often see in government policy documents, particularly in Asia, given its vulnerability to climate disasters, the need for also like resilient infrastructures and resilient technologies that can feed, be it environmental monitoring or any kind of resilience activity in the region. So thank you so much for that introduction to your work. You both look at climate data from different lenses. You're looking at environmental data, you're looking at climate data, and in particularly different geographies. So perhaps, Hanyuan, I can come to you first on how you define climate data. What is the kind of data that you use from your work? Where do you source this data from? And I know you made references to information around ESG, etc. So if you could build on that answer a little more, that'd be great.
I think what we begin with, since we had ChatGPT or other foundation models, like it opened up a new window, with different level of access of information. But if you go to still today, like the foundation models, it's hard to adopt them in the professional sector. So in the climate sector, we're talking about, that's where we started. So we work around quite diverse data. But if you need to make a segmentation, we have three types of information data we work with. And number one is, of course, the public information. Like we also provide the real-time access through RAG. So every time you come to ask a question on climate platform, not only the answer will provide you the link to the source. And then the second type is we call it semi-public. So it's public, like a policy or IPCC report, but you actually need a very complex data processing to make it more traceable or accessible. So that involves a stack of like segmentation or to annotate, that we need to set up the proper prompt in order to get the correct information and information ranking. And then the third type is our private sector information. So we also create our own data set. For example, we recently got a internal projects, summarizing information from SBTI. So you get the landscape of the emission disclosure and also carbon neutrality goal from the company, especially the non-listed one. So those requires people knows about what are you doing with the data, but also the data science sector. That's like a three category, and then the type of information can be very diverse. So I couldn't make a full list here. And then as more projects we're working with, the more sector, or we'll also dive into know what kind of information people are looking for. But I want to wrap up this question by saying not just in climate, if you look at the legal or medical, whenever people are adopting large language model today, the data is for sure the number one step, like allow you to use it better. But it's beyond the data set. We often got cases like our client has data, but they know they're not utilizing it well. And then in order to give them a tool, like a tailored version for them, a large language model, it's a lot of work, like understand the use case, and then you reverse engineer how you set up for example, prompt, how you prepare the data well. And that's kind of like most of the day-to-day job like occupies our time.
Just to clarify, what do you mean when you say segmentation as a process?
Yeah. So give one example of IPCC. The very initial conversation, like where got the idea of Climind, is actually with Sir Jimsky. So he's a professor at the Imperial. And then we were at the conference. It's called the Oslo Energy Forum. Both of us were speakers back then, and he was still the co-chair of IPCC. And then I sort of asked a very naive question, like how come IPCC report is so slow? It takes like 4 or 5 years to come up with a report. Then he walked me through the process of how scientists are coordinating all over the world and then come up with a report. And then so it came to me, okay, it's a perfect scenario, we can use AI. But the question is how. So segmentation here, for example, is each report is 100,000 pages, and then comes up with like a lot of graph, table, very complex format of information. So something we're doing is we need to make chunk of the document. So it cannot be too small, it cannot be too big. If it's too small, then it's a hard, or it's also a computing issue, and also how you can rank and how you can organize the output. If it's too big, then you might avoid content when you have the information. And then there's you embedded the language after the trunk, after segmentation, you embedded them to make sure it's searchable. And then using AI and RAG. So that's a very like a broader description, but it's definitely more complex than this. But segmentation is just one thing we do.
Just to follow up on what you also said around data processing and how a lot of time goes into that, what's the kind of expertise that you need like at your end for labeling this data, for annotating often like complex data from IPCC reports? And are there any challenges that you also face during this data processing stage?
Yeah, I think there's no difference with other sector trying to adopt LLM today. Annotation is slightly, I think it's slightly different than the traditional like AI sector. I mean, for now we work a lot on the text-based information, so reports with different formats. Climind AI give you the output, but we need to compare that output to the so-called gold standard. But the valuation metrics can be very diverse. So still taking the IPCC examples, IPCC has some official like question answer if you go to the website today from the reports. So this is actually my college thesis at Tsinghua Schwarzman College. I did a model benchmark, comparing the same group of questions, and I'll compare the output from Climind, from GPT-4o, from DeepSeek. Well, we didn't have DeepSeek back then, but comparing different results, and then you see how different they are. And then the gold standard, I was borrowing the IPCC's official report. So the annotations are complex because in the climate sector, or the sector working on, it's not really, it's not always a fact based. Like for example, ESG is a volunteer report. Like a lot of content is actually reported by company with a volunteering behavior. So it's not like a scientific you can give a 1 or 0 score, which is clever or not. So we're highly relying on the expert feedback. So you need to make sure when you construct the benchmark question, you need to be comprehensive. It need to be like right on the spot, and also you need to make sure that enough sample and making sure your sample can represent the population at a certain level. And that's like one example with IPCC. So a lot of our, I think, annotation or data work, first is you need to clean them, you need to structure them, and then that comes like how we make sure we have a certain level of accuracy record or different statistic matrix. And then we need to evolve external experts to comment on our output. And it's not a 100% score like we are able to get, or the ROI doesn't make sense. So depending on the scenario, I think the most challenging part is actually define the question. It's kind of like back to college statistics 101, but I think sometimes defining your hypothesis is more important than anything else. So that's, I think, the key thing here. So our team, we need the people who understand, for example, in carbon market, the logic of how the offset works, why we have the DVD, and then what is the registry. And also need people who can work around those information, those data.
Fascinating. Thank you so much for that breakdown of what really happens behind the scenes of building these models as well. Elif, I'll turn to you here. And given your work on open data, what are the kind of challenges or primary challenges that you have identified in the context that you work in when it comes to accessing data about the environment?
I think one thing I learned from the study in Fukushima was the importance of instrumentation as a pre-step for producing good data. And that's kind of how I got into the question of environmental data in the first place. I got really serious about instrumentation and understanding how data is produced in the first place. And then from that, I started to look into practices of data management and stewardship for producing environmental data that will eventually be collected in a number, in an amount that is sufficient to train a model that is useful. So I came to this work after doing the study on instrumentation. I was invited to join a group of researchers, environmental researchers, studying in Alaska, in the North Slope of Alaska. So I've been involved with this project for about 4 years now, which is a long-term study of the impact of climate change on the built infrastructure of Alaskan villages in the North Slope, indigenous villages. And we are studying one particular site, the city of Utqiagvik in the North Slope. And one of the challenges I came to appreciate in the work that environmental scientists do is how hard it is to produce good data, how hard it is to keep the instruments running, year round, how hard it is to prevent the instruments from being, destroyed, displaced. Just to give an example, we have like probes on the ground on the permafrost that measure different depths of the permafrost, and they collect data on an hourly basis. So these probes move around. So we have to be very vigilant to keep them in place because we'll be producing data all over the place as they keep moving, right? And that's just one simple example of like something that is really micro scale that will reflect on the quality of the data that will eventually will be used for training large models for predictive purposes, or even for classification of damage, for example, to the infrastructure in Alaska. So one of the things I think, to summarize this conversation about open data and environmental data, I think for me, from my experience, what I've been observing, and to the extent of my experience in the space, I think data quality has been a really important thing to be really mindful of. And another thing is stewardship, the sense of actually creating a governance layer around the data production that will have a positive impact, or will create possibilities for the community, for the local community, to actually put this good data to a good use. And these two things are really difficult, right? It's really difficult to produce good data, and it's really difficult to produce data that can then be transferred, that can be put to use by community organizations. And when I say community organizations, I'm thinking about, the local indigenous organizations in villages that have been affected by climate change. In the context where we work, we have one housing authority that is really concerned about the impact of climate change on the structure of the houses around the village, because as the climate shifts and changes, you have instability in the permafrost, and that impacts the structure of the houses in the village. So that one example is the high school in the villages. One part of the high school has a structure that is damaged because of the permafrost instability. That's why we're super interested in studying the permafrost. So I think these two things, I think data quality and then data management and stewardship, I think are one of the key things in the space that we need to put more funding, we need to put more attention to actually have better applications in the space.
The permafrost example is quite striking, and even when we were doing our research on conservation and AI, like there was like one of the issues like around instrumentation data collection that we were coming across, that it's often hard to like put, say, camera traps or data collection devices in terrains that are not really built for humans to go into, or like even you can't even walk up to, say, the inside of the forest. So that's a very striking example. On your point on stewardship, and this is also something that's like we come across when we are looking at community mobilization around data infrastructures. We see that building that cohesion both among the community members, like within community groups, between different community groups, might be challenging given like competing interests. So say, for example, some members might see some value in a stewardship model, while others might prefer a more detached approach. They might not want to be learning more about, say, data governance or how to be using climate data. Is that something that you also come across in your work? And if there are those competing interests, those differences in opinions, how do you navigate that in the context of community data stewardship?
Yes, I think this is a very difficult problem, and I've read about this problem in the literature. I experienced this problem firsthand, and I continue to encounter this, and my colleagues continue to encounter this problem. So there's no easy answer here. I think one thing for certain is that people who work in the space know that community is hard work. It's really hard work, and the conversation about data stewardship, community data stewardship, is in a very fraught space of environmental organizations. They're publicly funded, private interests in creating, climate applications that can be profitable. University researchers, university students, community organizations, and environmental justice organizations that are not necessarily aligned with community organizations. Or they might have a different kind of politics. So this space is really fraught and it's really difficult to navigate. So some of the experiences that I learned about that are really, really positive and managed to push the needle in this space are experiences where the hard division between the expert and the community member is blurred or is bridged in very interesting ways. So I'll give you an example of an experience that I came across in my work in Alaska. The National Science Foundation in the United States funded something called Community Office for a big funding program called Navigating the New Arctic, which involves researchers in different areas of climate research studying the Arctic. And this is U.S. funded projects, of course. Like the Arctic involves much more than just the United States, but that's just for the corner of U.S. researchers and their international collaborators. And in the context of the NNA Navigating the New Arctic Community Office, I realized that there was a really interesting model of bringing community members, community organizations, researchers from all walks of life, students, senior researchers, people working in different aspects of climate change, to collaborate and to discuss common problems, the issues that they see. And the conversations are really difficult because community members in the Arctic will say, look, like you have been studying a problem for the past 20 years or 10 years, and you come here, you ask for help, you collect data, and you never show up again, and we have no idea what you're doing, and there's no return to the community. So I see, based on the experience of the community office, that researchers are making an effort to discuss and set agendas based on community needs. So the community is driving agenda setting. And when it comes to collaboration, much more effort is put into training and also making sure that what is produced by scientists actually returns to the local governing bodies to result in practical policy implementation. So this is one example. I have others to offer, but I think this is a powerful example. You create an interdisciplinary space of mutual respect where the hard division between experts and non-experts is bridged. So we get to learn from the experience of community members who have tons of knowledge about the climate change in their context, and scientists who are not experiencing the everyday changes in Alaska, but come every summer to study the site, right? It's a summer research site for many of them, for most of them, because most colleagues teach throughout the year, including myself. So I think this is a positive example when it comes to the conversation about stewardship, community data stewardship.
Thank you so much for that. That's a very powerful example of mutual learning and knowledge sharing between experts, and as you said, bridging that between experts and non-experts. And as you also said, like how this was funded by the US, like a very small part for the Arctic. And I'll use that as a segue to also then talk about financing in the climate sector, especially at the intersection of AI and climate. And maybe Hanyuan, we can start with you first. What are some of the key tensions or gaps and nuances that you've seen in climate financing for AI solutions in the region? And what kind of funding models are you seeing that seem to stick, especially given the long term costs of building and maintaining technology infrastructures?
Yeah, so I think that's a question very relevant to like us startups. I think we can break it down into two categories. For early stage startup, and then here and also for late stage projects. They're usually having different financing mechanism. I can give more context, like think from our experience. But for the second type, like for example, the big projects like adaptation mitigation projects like uh, nature-based solution, those are usually goes to I mean their type of financing source for them like blended finance, a mix of public private sectors. But for us, like the technology sector, I also realize it's a quite special position we're sitting at. On one hand, I would say opportunity first, then I'll come back to challenge. Opportunity on one hand, there actually tons of grants, competitions available in the market, like founders can apply. We bootstrapped it by, for example, in Hong Kong. Hong Kong has a science park. So science park provides us grant, like equity-free money, like for a company, like who got selected, you can kind of finance throughout the 3 years period, and then every milestone you meet, they will unlock sort of capital allow you to keep running. And then in the meanwhile, like it will also close around recently, so venture capital. I think still that's like most expected or traditional ways of financing a startup or technology. I think like the opportunities for climate tech is apparently they're fund like a specialized or set up for climate technology. So the supply is there. And then the second is also it's encouraged by most of policy. So for example, we just came back from Singapore. Like Singapore is actually, I think, the first country set up the carbon tax, like a very serious level. And then there's like a sort of quota you can use from the carbon market. So that gives a lot of incentive to the private sector to finance like solution relevant to the scenario. So those are like opportunities. The challenges are pretty obvious. And I think the number one challenge is people's suspicious on like whether the business model makes sense in long run. I think those are the number one thing scared venture capitals or investors in the sector. And then the second I would say is the misalignment or like lack of incentive of the sector. So what am I investing in, and then what kind of return I can get? I guess those are questions like people financing this sector will be. But I want to end with one recent observation I got. I just did a work tour in the state and then traveled a bunch of climate school in universities. And then my observation is a lot of the climate school established today, majority funding source is from private sector. So it's relatively less impacted by the Trump policy. And then the second is it's becoming a very popular major for students. For obvious reason, I think at some school it's just second, like just behind computer science or like popular traditional majors. So I guess the momentum is there. When you have momentum, you have a usage, then naturally, like I think the more traction comes in. And then if you do a simple math in some country like in Saudi, they're gonna be like I don't remember correctly, but like 10 billion trees in a couple of years. So the demand being created at a massive level. So they need the supply to fill in. So I guess that also creates some opportunity to answer the challenges I just gave in the financing part. But overall, I hope like more founders like us can survive the very first 2 or 3 years because that's the hardest time, like whether you can survive as a company. And then once you go at a certain level, then you realize there are a lot of opportunities that you can deploy your technology and then you can grow from there.
Just to follow up on that, like I think it's an interesting insight into how climate schools are being funded by the private sector, and then they're not necessarily affected by the recent global uncertainty in climate finance, with the US pulling out of loss and damage and the Paris Agreement, etc. But outside of the climate schools, like specifically for climate tech or AI interventions in climate, do you anticipate a shift because of this uncertainty around climate finance more globally, given in Asia's context?
Asia for sure. I mean I'm from China and then but I did my school in UK, US, um, and then also did it in Hong Kong, China. So my comparison is, especially right now, the interest of climate is actually increasing in Asia. We can see more events being launched in Hong Kong. And I went to Tsinghua, so Tsinghua has a lot of climate-related research department joined research lab. We had the climate center actually contributed to China's 3060 goal, and it's only getting increasing. And then China for now is the largest ETF in the world still. So I think the Asia sector, the demand is actually increasing at a bigger scale than what I saw in the state. And then the supplier, I think, is warming up. I can give you an example in Hong Kong, like a Hong Kong University, they launched the ESG center, like a sponsor funded by Jockey Club at a very big scale just 2 years ago or 3 years ago. And then the University of Science and Technology also has one. And we're also working with, for example, Hong Kong Baptist University. So just Hong Kong, like there are already a lot I can come up with a number with. Um, and then with regarding AI, I don't know if like it's our good pick or some reason like there are more and more topic discussion about AI and climate change. From what I heard, I mean there's just the ICLR conference we attended. The topic is AI for climate. And then I guess the interest comes from, I mean, both are a hot topic, but also you see the efficiency what AI can bring in the climate sector. It makes a lot of sense in the calculation. But also there are areas AI can do that human cannot, like regarding material or I mean renewable energy. I guess it brings a lot of opportunities that people have hope for that also create the interest more and more people jump into the sector.
Just also picking up on the point you said around ESG schools, etc., coming up in Hong Kong, like in that context, across our podcast series, also we've had experts express varying opinions on the efficacy of ESG as a concept itself, but it seems to play a dominant role in assessing corporate accountability within the sustainability conversation. And you've also done some work on an ESG tracker. What is your take on ESG in climate finance, and what role do you see it playing in an increasingly technology mediated landscape?
We have, to be honest, we have a lot we want to work on in the ESG sector. Well, the reality is we have too many standards, and then we're creating more. I mean, the introducing of ISSB's new standard is a good news. I hope like can align many different voices to report with the same scope on the standard. I personally contributed to the recent textbook of SDR on the chapter of climate risk, so I had a chance to read a lot of regulations like standard all over the world about related to ESG and climate risk. And then my quick summary is we're not getting there yet because ESG is kind of like the data, the very foundation layer, how you access the company's performance on the sustainability. So if we're not agreeing on ESG, the data layer, none of the work based on the ESG can be solid. So it's hard, I think, to agree on one voice soon. So I mean that also brings I think some opportunities in ESG, like for example, how can you streamline, how can you leverage AI in the reporting side, or how can you use AI interpreting, understanding the ESG report, and so that's like a two very obvious uh, scenarios you can use AI in the ESG sector. But I don't think those are very exciting opportunities if you want to build a company on top. It's not creating more, it's not, well, you are accelerating the sector, but you're not creating more exciting opportunities, I think, for people working in the sector. I mean, we're working on this report, we wrote the report for our stakeholder, our investor. Um, it's not fun. It's like a very long process, back and forth conversation, internal, external with a company. If you work with a big company, then that's a nightmare. So I think it's a necessary job. You don't want to replace everything by AI. It's hard to as well. My hope is I think if people can, well, the regulation, the legislation can figure out a better way. We can skip the tedious process, like adding so much burden. And the key thing here is that we want to access the performance of the company's ESG. Well, what if we can just get the data directly and then to give a score rather than getting so many reports every year. And then you have so many work being created to read the report. It sounds like so unnecessary, but I can be wrong. And also, we're still trying to do more case study in the sector. So welcome the audience if anyone in the sector having some good ideas we can discuss.
Amazing. Yeah, that does definitely sound very complicated. Just to clarify, when you say that there's perhaps some disagreement at the data layer for ESG, what are some examples of those differences in opinion on what should be data, what should be these standards?
So usually a report has certain components, but some standard ones are you can see a table in the end appendix, like what kind of standard rule they fulfill. Usually like a GRI or depending on which legislation jurisdiction you're at. In Hong Kong, like Hong Kong has its own one. The misalignment, I give one example, even just for emission. Within report, disclosing scope one, scope two only, and also seeing company breaking down the scope two into many different categories. And then it's very rare to see scope three disclosure. So I think, I mean, for emissions, still easy. Like you know the math, you know the formula behind. But if you want to measure like the water management, it's very hard uh, to compare. You can't compare with apple with banana. It is different sector. Then it's very hard to sell like which company did more work in the water management.
Right, that makes sense. Thanks so much for that breakdown also of just the complexity of ESG reporting and self-reporting in this space. We'll do a complete pivot here and come to you, LF, on the question of community-led initiatives and financing around that. As you were saying, participatory processes are hard, but then over and above that, forging these multi-stakeholder collaborations and community-based partnerships, they're time-consuming. They often require extended periods of trust building with various partners. And in your experience, what kind of funding models best suit partnerships like this?
Well, I don't think we have a good answer for that yet, quite yet. And I will tell you why I think this is the case. In the context of another project that I've been working on called C Commons, Social Environmental Knowledge Commons, we have been working with the concept of the common as an alternative between two approaches to environmental governance, environmental action. And this is something we elaborated based on our experience, based on the literature, based on the work that is happening, the debates that are happening in the context of the climate research. So we came up with the design for the project around the common or the commons as an alternative to two forms of management. One is public and the other is private. And we did that by basically acknowledging the shortcomings of both in treating the difficult challenges that we have ahead of us right now and ahead of us when it comes to the climate crisis. One, in terms of the public, with respect to environmental regulation and the challenges in that space that we always fall short in regulating so-called bad actors in environmental space. And this is a historical problem that we still need to solve, and we haven't managed to find a solution. And this is something that is happening at all levels, if you think about it, right? From the local level to the regional level, to the federal level, to the international regulatory space. How little we actually manage to actually do in terms of international environmental regulation, despite decades of debate of environmental governance and regulation at an international level, right? And then that's on the public side, right? But then when it comes to the private side, we have seen after a wave of conservation policy, and then environmental activism, a wave of financialization of the climate conversation, and the creation of financial instruments to actually try to address the problem, right? And this is also a space that has been very complicated because you have at the base the engine of financial instruments, the logic that is basically supporting the extractive industries in the destruction of the environment. So you have a fundamental tension in that space that needs to be solved, right? If you have like capital as the engine for that space, and a capital is at the source of environmental degradation, historically speaking, that led us to where we are right now. So how do we solve that tension? So back to your question. This is a long preface just to get to your question. So the idea of the common as a mechanism to actually address this. If we pull resources with the logic of commoning, the logic of the common, that is not private, is not public, but it's something in between these two modes. We might have a better chance of coming up with something that will be more effective in responding to the climate crisis. So how do we do that? Again, I don't think we have the answer yet. We're experimenting with different ways of doing this. But one thing that we have been doing, and I think it's working modestly. It's not working very well. Is to actually pool resources, from public funded research projects, from community projects that are volunteer based, and from private interests that are actually providing resources for us to conduct research projects that are community based. So pooling resources with this logic of commoning, because we have a common challenge that affects all of us, right? Regardless of social class, regardless of geographic position, it's a common problem, and people are affected differentially. Like there's different levels of harm depending on where you are, right? But the common challenge is very common. It's clear that it's common. So if we start pooling resources and creating these forms of commoning and collaboration, we can go really far. So if you take private funding to do data curation on a particular data set that's very important for the community, that data set is going to be used by a local community, is going to be used by researchers, is going to be used by people who are writing reports for policymakers, is going to be used by folks who are creating models that can be used, by researchers and community members, etc. So there's this virtuous circle that can be created by commoning practices in the space of environmental research and action, that public mechanisms only or private mechanisms are not going to be able to provide us. So we need a different logic, and we need to come up with something that is more robust. So I started by saying that we don't have an answer, but we have an intuition, and we have a set of experiences that actually worked in the space of commoning and creating common resources, common pool resources, and managing them well, historically speaking, that point into that direction. So this is a very long-winded, very complicated, convoluted way to get to your question, but I think that's kind of like how I would approach it without answering it, because again, in sheer honesty, I don't think we have a good answer for that question.
Thank you so much for being so candid about that. But I think your answer is also great because you've pulled in not just like the financing aspect of it, but also around like governance, management of the data, who is it for, how does it serve community interests, and bringing in like different tensions in that space. So that was a great answer for sure, and I'm sure our listeners would enjoy listening to that. And using what you also said about like just this financialization of climate narratives, of the inclusion of private sector in this space, and the kind of perhaps funding models that we're also looking at, the kind of capital assets that we're building. And Hanyuan, I'll pose this question to you as a kind of final closing off also of this podcast episode: how climate tech startups and VCs or venture capital also kind of gets lost in this language of return on investment and kind of maximum impact, often missing the woods for the trees in this case, like not really directing interventions to the most climate vulnerable populations, perhaps because there's no profit in those, or being guided by considerations of equity or climate justice. What would be your two recommendations for startups and investors working on solving the most pressing climate issues in the region?
Yeah, I couldn't agree more what Liz just mentioned. And then to for this question, I think for it's very hard to have one solution for all stakeholders, and especially climate involved. So we need effort from many stakeholders. For startups, um, the model, like how I guess climate startups are doing fundraising, the calculation is also different. If you measure by the revenue, I mean for early stage, if you measure by traditional metrics, it's very hard to tell the I think the true value for the company. So the traditional way of ROI, I don't think it works. So for a startup, I think the challenge here is how you present your long run value, but also the commitment that you're gonna do it to make the commitment. I guess that for investors, I think for my category, is there investor investing in climate and not? So those are very different folks. If you talk to people who invest in climate, they have their own thesis. So you can speak pretty much skip the conversation of why. That those I can share like my conversation with our investors. Usually, the metrics they're looking for, they have their own ways of measuring the impact, either from or some business perspective, like a number of users, recurring users, but also like how many or how broad the population you are making impact about, and also whether your solution product can fit into the basket of the portfolio. Sometimes that can also be a very important one. And then I guess for people who do not actively uh, invest in climate yet, the investors, I think the issue, the challenge here, or the missing puzzle here is how the existing business are negatively impacted by climate risk. Once they figure out like that's for real and it's measurable, then it will be easier, I think, to get people's attention in the sector. And then we know like the pension or like endowment are those kind of like original force, like forcing original energy, like forcing the attention in the climate finance. And now the global voice is we need more private sector investment. I always believe like a business is the most efficient tool to solve problem. We need NGO, we need public policy, we need government. But I think the core thing here is how can create an economy model that encourage people to do better things, not punishing people by doing bad. If we can make that right, I'm sure like people are happy to do things good. And then like it's also I think unfortunately the solution usually is not directly solving the people who need the support the most. I mean, in some country impacted by climate the most, and they not who causing the problem. And then the solution is not usually just cater for them. I mean, some are, but I think we should look at the global perspective. Like, if local optimization is possible, it doesn't mean like a global optimization is possible. So I hope like there's both supply demand of innovation, of innovation can be higher in the future. And then just to see the number, like how many climate school being created, that's for sure for a reason. That this industry is not going to disappear. And then will have more jobs. Like they have so many things they can work on. So in general, I think the old way doesn't work, but that's how you disrupt the old business, as always.
Thanks so much, Hanyuan, and just also speaking to what you were saying about better innovation, perhaps more local innovation from different regions, and perhaps more support for communities developing the solutions. LF, I'll turn to you here on like you've been working in this space. You also highlighted some examples of collaboration, participation with communities between researchers and developers. If you had two pieces of practical recommendations for people who are already working in this space or trying to develop solutions or trying to work with communities with climate data, trying to develop AI solutions in this space, what would be those recommendations be for a more sustainable, equitable climate future?
Well, the question of AI is a delicate one in the space, right? Because many community organizations, environmental justice activists are basically refusing AI as a response to anything related to climate issues. I I think there's a space. There are fascinating problems to be solved in the space of artificial intelligence more broadly. But when it comes to the application, I think we have a long way to go to make the tools really useful, really efficient, and address the problems that we have. So um, one of the things in terms of practical suggestion, I would say we need to do a much better job in curating data, useful data, and sharing data for training useful models. I think this is something that needs to happen much more. There's still a lot of resistance to data sharing. That, of course, impacts any attempt that you might want to develop in the space of AI. Another thing that we need to really do is that we need to be very careful in the applications of AI because indiscriminate AI use is actually detrimental to any environmental action that we might want to engage with, given, of course, the environmental impact of digital infrastructures that are necessary to run a robust AI application, right? Especially if you have a large base of users, you start having like really serious demands on digital infrastructure to actually support it, right? So I think if we start identifying common tools that we can use, and we are very conscious about the use for really important modeling work that we need to do with artificial intelligence, I think we'll put artificial intelligence to a really good use in the near future. But if we continue on this trend of indiscriminate AI use, and also indiscriminate upscaling of digital infrastructures, even in places with water scarcity and other problems. Like this is a really worrying trend in the space. That I think in terms of a practical advice, I think will be good to avoid at all costs in form of AI application that actually creates more of an environmental impact than actually responds to environmental problems we have, right? So there's still like we don't need to just, of course, like be avoid AI as the domain of research and development, but we need to be extremely careful with the applications of it because right now we're experiencing a gold rush in the space of AI, and that is extremely worrying because that does not help us at all in addressing the environmental problems we have. It's quite the opposite. It actually adds up to the problems that we have with digital infrastructures and demand on the digital infrastructures, and the need to create more and more and more and larger digital infrastructures to actually support AI applications. So that's kind of that would be a practical suggestion that I would have.
Thanks so much for that. And thank you for also ending on a rather somber note on navigating almost these tensions and how do you balance AI's environmental impacts against its promised solutions And because a lot of AI interventions, they right now are a promise of future good, and we're also seeing conversations around how AI can be used as a distraction to move away from actual politically driven climate action. So that's I feel a great note to end on. Thank you so much, Hanyuan and LF, for being with us today, for sharing your thoughts and insights and your work. I'm sure our listeners would have enjoyed listening to you. There's definitely a lot to chew on, and we're glad you spent this time with us. Thank you. Our podcast speakers have spanned diverse professional backgrounds and geographies, from academia to policymakers to startup founders. And yet they have all agreed on some core principles. While AI may have useful applications in climate action decision making, industrial decarbonization, and biodiversity conservation, we must prioritize the needs of climate vulnerable communities. Moving beyond narrow metrics, silver bullet solutions, and a focus on immediate ROI is essential for creating solutions that are not only effective but equitable. Finally, the adoption of participatory technology design and problem diagnosis are fundamental starting points to safe, trustworthy, and effective climate AI applications. As we close our series, we reiterate what our guests have urged in as many words. Pause and reflect on the suitability of machine learning and generative AI for climate action, build opportunities for multidisciplinary collaboration, and don't forget the environmental and social costs of our digital growth trajectories. Thank you for tuning in to our final episode. A big shout out to our hosts for the series, Urvashi Aneja and Jayan Sriram, as well as our partner, Earth Venture Foundation. For those of you who have been with us since episode 0, we hope these conversations have sparked new ideas and reflections, and perhaps even caused some discomfort, nudging you to rethink your frameworks for understanding climate and AI. If you are a first time listener and curious about this intersection, please explore our archived newsletters and podcasts at codegreen.asia. Till next time, I am your host, Donna Matthew, and on behalf of Digital Futures Lab, thank you for listening.